I'm going to talk a bit about Gradle 2.0 and beyond, so what were the latest efforts in the Gradle open source project, what's the current status, or what we're currently working on, and I will talk a bit about the roadmap, what we try or plan to achieve in the next couple of months, and hopefully months and years. So my name is René. I'm working for Gradle, basically the company behind Gradle. We're doing consulting, sponsored work, training, all that kind of stuff. Yeah. So, who never used Gradle before? Okay, so I won't talk much about basics. So that's all I have about basics. So in a nutshell, that's how Gradle looks like. You have plugins you can apply. A default or one word for it's a groovy DSL. That's probably why I'm speaking at the Greach here. So it's a groovy DSL, and you can have plugins. For example, plugins brings in two things: tasks and conventions. Yeah, let's keep it that way and say. So Gradle is task driven. Yeah, and the groovy DSL, it's easy to use all kind of groovy features. You want to have reading files, doing URL stuff, whatever. We support different repositories for dependency management. JCenter, for example, is a famous one, Maven Central, or you can declare your own one based on Maven, Ivy, or your custom file directory layout, whatever. So, and the way you declare dependencies is, have you Maven before, those guys? Yeah, okay. So, usually you reference a dependency by defining the name of the dependency, the group, and the version. So that's what we do here. And you're not restricted to use plugins. You can write your own tasks, so that makes it really easy to tweak small things in your build. Yeah, that was a great intro. So, now I want to talk about what happened with 2.0. So the Gradle 2.0 version was released in July 2014. So the way our deployment or our release process is working is that Gradle 2.0 does not have or didn't have any big new features. We don't do any big bang releases or something like this. The versioning for us is more some sort of a compatibility thing. So by releasing Gradle 2.0, we were able to remove all the deprecated API, which slowed us down in adding more and more features, so we have to maintain that stuff. So that's why basically Gradle 2.0, our CTO, so Adam, once said in his talk about what Gradle 2.0 will do for users, and he said in general it will just piss the users off because all the deprecated API is removed and some new features but no big bang things. So yeah, that is what Gradle 2.0 is about. The latest version was Gradle 2.6, released in February. Usually now I explain that we release every 6 weeks, but I won't do that now because it doesn't fit here. Since Gradle 2.4 is not yet released, so usually, yeah, we have a 6 to 8 weeks release cycle. Yeah, we run a bit later. So a lot of stuff happened between Gradle 2.0 and Gradle 2.3. Some of the highlights, I don't have the time to name everything. Yeah. So there are small things, especially interesting for bigger companies or build masters who maintain large builds, so you can now easily share your configuration files across builds. What I mean by configuration files are things like check style configurations and stuff like this. So it's quite easy now to declare that as a dependency, and you just pull down your, for example, check style from your local repository, whatever you want to use. Gradle evolved to be not just a JVM build system anymore. We also added we spent a lot of work in doing native build support. So you can now build all kinds of native apps with it. So C++, Objective-C, C, Windows resources, if anybody's using that. Good for you. And you can even build assembler with it. So Windows, Linux, whatever. So yeah, that was tough to write the integration test for that, but yeah, it worked out. Yeah, the native build support is quite good, and we are still working on that. So we have simplified cross-compilation support, parallel compilation support will be in 2.4, but I guess we're Ruby users, so we don't care. So another thing we worked on, or it's a general process that we work on dependency management improvements. So we added support for SFTP-based repositories, so you can now have your Maven or Ivy repositories sitting somewhere in the S3 storage. Oh, it's a typo. Yeah, SFTP-based stuff was introduced in 2.1 or whatever, and 2.4 will have S3 support too. Another thing we added is an artifact pre-read API. So we, the developers of Gradle, and some of our users, most of them, I think, are convinced that Gradle is the best dependency management out there in the build system, ecosystem, whatever. We take a look at this closer later. I will prepare a small snippet. We also currently working on play support. So there's initial play support already in Gradle 2.3 or even 2.2, I don't know. But it's still, yeah, there's more to come. I cover that later on. And we have now a plugin portal in the former days. I don't know how long are you using Gradle. The plugin portal was the wiki page, which was not updated. Yeah, it was hard to track plugins or find the right plugins. Now we have a central place to do that in the plugin portal. So that's how it looks like. I don't have Wi-Fi, so it's screenshots first. Yeah, you can search for all kinds of plugins and buzzword, Docker. So, there's a Docker plugin too. There are multiple Docker plugins. So let's prepare a small demo. What could you demo at a Ruby conference? Play support maybe. So the way, let's take a look at we have a simple play app here. So anybody used play before? I saw a couple of people. Anybody? Okay. So this is a basic play app, more or less the one you generate per default. You know the routes, the application count, whatever. And if you look at the build.gradle file, that's what it usually looks like. You use a plugin play. You declare your repository where you want to resolve all the play dependencies from, which is usually type safe repository. Here, if we want to build it. You see the routes get compiled, the 12 templates get compiled, and we run the tests, which we could find in the right spots. So that's it. And you can also run the app. So if you say Gradle 1, you can run that. Actually, this is lying because it says auto reloading enabled. It's not. That's what we're currently working on. the issue is that the API of play itself claims that auto reloading is enabled, so that statement comes directly from play. But they expect to, in the format, on the first one I implemented this, they were saying SBT, blah, blah, blah. Well, no, we're not using SBT, but we're using play. So, yeah, but they fixed it for us. It's interesting because there's some play developers out there, or not people using play, people working on the play platform, who are really keen to use Gradle for that. That's a nice thing for us. Yeah, and if you run it, use. So another thing I want to show is the artifact query API, and the reason why I asked if you have used Gradle before is we're going quite deep now. And yesterday, Andres already mentioned that Gradle has a deep API compared to, let's say, Maven or even the polyglot Maven, where you declare the problem in a Groovy file, but that does not really change anything because the model didn't get deeper just because you used Groovy for that. But we will look how deep actually the API is in Gradle. So I can run Gradle dependencies to list the dependencies I'm resolving. So in this example, I'm using SLF4J API 1.7.10, and the reason for that is I just want to have the latest one. I want to have the plus version here. Plus means give me the latest one. In general, that's nothing I suggest for customers, because what's the problem? Maybe short break. What is the problem with that plus annotation here? Or general using that kind of dependencies? Which is crucial for builds. Exactly. Reproducible build. So if you run that build to build your release, let's say, you get version 1.7.10 as we have seen. Now let's say you move on with your work, and after 6 months or whatever, somebody said, well, you have to fix something on your release branch or whatever. So you check out this exactly the same build file, you haven't changed anything, and you run your build again. You're not able to reproduce the same behavior because Log4j has released different versions since then. And that's why I usually tell people don't use dynamic versions. I think we in Gradle, we don't use it at all. The only place where I often see is JUnit dependency that might be okay, but even that is not 100% safe. So now, let's say I notice that the 1.7.10 version has a bug in it, so what can I do? I could now change it to declare specific dependency to depend on 1.7.9, but I could also add what we call a component selection rule. So I say, okay, if you ever resolve SLF4J API, please run this selection rule. So what I'm saying here is that, okay, if the version you selected or as a candidate for being used is a 1.7.10, and I know there's a bug in there, please don't consider this one and reject it. And you can add a message to that. You can say non-buggy version. So SLF, we know it's buggy, and now we run it again. We can see it's using 1.7.9. One issue here is that there's a bug in Gradle. That's usually what you figure out when you prepare demos. That the message we just provided, the non-buggy version, is just shown if you run it with info logging, so that's something we need to fix. But you can see now when you run dependencies, it's telling you, okay, I take 1.7.9. I would have chosen 1.10, it's a newest one, but it was explicitly rejected because you say it's a buggy version. So let's take a look at the artifact query API. So sometimes you just not want to resolve your main artifact, like your jar. You also want to deal or want to do some more stuff with, let's say, with the POM for it. POM POM files contain different information. It depends on who deployed them, like developer information or license information, stuff like this. So let's take a look at how to get to POM files for our dependencies. So as you can see here, that's what I meant by deep API, calling configurations, compiled incoming, resolution, result, all dependency, collect, and now give me all the from all selected IDs, and what I get out of that are all the component IDs of my compiled configuration, and now I can say for those components, resolve me some specific artifact. So I create an artifact resolution query for those components, for all the components in my compiled configuration. And what type of artifact do I want? In that case, I want that for. So for all Maven modules I resolve, please give me the Maven POM artifact. And and what I do then, just as an example, I iterate over all the POM files I get, and extract information out of it. And since it's XML and you're using Groovy under the hood, you can easily use the XML slurper, for example, for parsing XML stuff. Pretty simple. So just in that case, I just want to print line the URL, which is provided by the POM. So we run that resolve main POM files. Yeah, and it just prints the SLF4J API. A couple of years ago, when I worked for my former company, I had a student there who I wanted to implement something like a license check. And that would be really helpful if we would have had that feature already, but it was 4 years ago or something. And he didn't even appreciate working with Gradle 4 years ago. So another example, I just have 45 minutes. What I do is I want to resolve source files or source artifacts, and I want to resolve the Java doc for my dependencies. And here's the same approach. I collect all component IDs. And then I create the query, but now I'm selecting for all JVM libraries, give me the source artifact and the Java doc artifact. And now I can iterate over the results. And print out the file. Or basically it gives me a reference to the file that you can do whatever you want, package it into your distribution or reading it, whatever. So that's what happened between 2.0 and 2.3 more or less. Anybody with any idea what I want to talk about now? Tooling. Tooling. In the former days, the Gradleware and Gradle committers don't directly invested in adding support for IDEs. The first deep integration for Eclipse, for example, was written by the STS guys, the Spring Tool Suite guys. The main reason they implemented it was they moved to Gradle and they wanted good Gradle support. But in the long term, they somehow they skipped the interesting projects. So they don't wanted to maintaining that anymore. They gave it up more or less, and all our customers and all the users saying, well, Gradle, nice tool, excellent, but there are still developers out there who just live in IDE. it's just the case. And so what we needed to do is take care of that, and what we started with is we started writing our own Gradle plugin. It's called Eclipse Build-Ship plugin. The reason is it's called Build-Ship is somehow that if you want to have a plugin which is literally under the hood of the Eclipse ecosystem, Eclipse Foundation, they have some weird requirements about the name. I think we couldn't add Gradle somehow to, I don't know. It was officially announced at EclipseCon in San Francisco. It is a from scratch development driven by Gradleware. It will be part of the next official big Eclipse release in summer. So it will be already shipped with a mass distribution. And we completely handed over the ownership to the Eclipse Foundation. So the commuters are, some of them are still Gradleware, or most of them. So it's driven by Gradleware, but the ownership is the Eclipse Foundation. That's, I don't know, legal thing, and if you want to ship it with Eclipse, blah blah blah, that's how it is. I haven't talked about IntelliJ yet. IntelliJ had quite good support for Gradle, and they're really working on improving it. But I'm an IntelliJ guy. Who's using IntelliJ? If you can choose, but some people can't. So, okay, so that's what we're working on the tooling part. So what's coming next, or what we are currently working on? I have some stuff prepared. One thing I put first is because we just started working on that is some sort of a watcher mode for the Gradle daemon. It's driven by, it's partially driven by the Play support. So if the current developers of Play, they tend to use SPT because it's a default one for that. And one big reason for that is because it has this auto refresh functionality. So the cycle of development, seeing what changed and stuff like this is quite short. And that's in partnership with LinkedIn. We're now adding support for general watcher mode in Gradle. That will be really cool for Play, but it will also be cool for things like JavaScript development, where they tend to do that too. I don't know, JavaScript. And
will this replace that watch plugin?
Well, to be honest, I never used the watch plugin before, but in terms of functionality, it should, yes. Yeah, Markus mentioned that watch plugin, and you use it already for asking also. That hopefully won't be necessary. And another thing is that since it's deeper integrated in Gradle, you can have or can expect more features in the long term. So you can, for example, continuously, or you don't necessarily want to rebuild it, but you can, for example, already track inputs. So if you have, if you develop something, whatever, and when you currently invoke Gradle, you have the configuration phase, and then you have the execution phase, and you have, it calculates its inputs of the task, right? And what you can have you can have something like preemptive input calculation. So if you hit enter, you don't have to do the input calculation again.
Or that it caches the configuration phase.
We come to that later. That's another point. And it's, we have, I saw big builds, especially in the native world. Yeah, I worked in a weird setup where they had don't get this out. They had an NFS setup, network file storage, and it was damn slow. And they had, I don't know, they had millions of source files and header files, and I don't know. And that takes ages. the checks, because it's checksum based to be thorough. But of course, checksums are more expensive than time steps, etc. Yeah, so that's one thing. There's an interesting thing I noticed yesterday when I walked home from the party is that one of the, so everybody knows Pivotal dropped the support for Grails and Ruby, right? And we kindly gave one of the Grails developers a new home at Grailware, and the funny thing is that he is the core developer of Grails. His first project, or his first stuff he's working on is adding that watcher mode to support play better. It's a nice anecdote, I think. But the major, so the watcher mode is one thing. It's not that critical, or it's not that complicated compared to other things. Like we want to have faster configuration time. So at the moment, or other way around, the 2.4 release will be definitely faster than 2.3. We had some sort of performance camp where 3 guys of us met for 2 weeks and just focused on improving performance. And it was more or less grabbing the low-hanging fruits. But we saw that for some builds, the build performance improved by 20 to 30%. It always depends on your kind of build. Yeah. So the general issue with configuration time in Gradle is that it does not depend on whatever you invoke in Gradle. So you want to trigger the test task, let's say, and you don't want you want to build a jar, but not running the test for whatever reasons you shouldn't. But you configure all tasks that are declared in your build, even though you don't execute them. And it works for small projects to some degree, but it does not scale, right? So the biggest build I know of is a LinkedIn build. They have around 4,500 sub-projects. And yeah, initially when they started migrating to Gradle, they needed about 100 gigabytes of RAM. And they said, well, that's fine, if it sticks, yeah. And so I think they are now down to, last thing I heard was about 20 gigabytes, but again, they built 4,500 projects in 20 minutes or something like this. They're really ambitious, and yeah, we work close together with them. So if you have 5,000 projects, and you invoke one jar task of one of those sub-projects, all tasks for all 5,000 projects get configured. So every fucking damn invocation you need to configure that. And that's also affecting the IDE integration. So one thing we now discovered when the Android guys, or their Android Studio builds, or if you use Android Studio in the IDE, under the hood there's always Gradle running the build, so there's no different compilation in the IDE than on the CLI. But in the IDE it's massively important to get snappy feedback. So if you have a huge project and you need to if you trigger the Gradle build to get some information out of that, out of the configuration, you need to improve that to some degree, or definitely. I wanted to take a screenshot or a picture. Hans last year did a talk at the Gradle Summit, and he added a slide where configuration time 0. And the engineers were very surprised at that. But he lays the bar quite high. He could use the seal. So what we're going to do is we change the way the configuration is done. So we will have soon a new configuration model that only configures what is required to finish the build. So if you have just one jar task, it will just see what is necessary to get that jar task done, what configuration must be done. So of course, depending task will be configured, stuff like this. And the idea is that once we have that in place, we can, or with a new model, we can also take advantage of caching configurations. And that will make it even faster. And another thing to speed things up is that we generally will have allow parallel configuration. And not just a side effect, but also something we need to consider. I had a typo there. It should be just better visualization. Because at the moment, if you have a complex build and you want to figure out why is a task configured in the way it is, it's quite hard to figure out who is. It depends, of course, on how your build is maintained. But in general, it's hard to figure out who manipulates, for example, the task. So every plugin can hook in and add something, and you have this. I don't know if you ever use that after evaluation block, and it's not easy to figure out who does configure what. And at the moment, you have full freedom, so you have a build, and in one sub-project you can reference another sub-project which are completely unrelated, but we don't force it at the moment, or don't enforce it, so we can customize something already in there, even though technically it doesn't make sense and logically either. Another thing I already mentioned, maybe for those of you who attended the Android talk yesterday, is better dependency management. Again, we think we have the best dependency management in place, but there's much more work to do, I think. At the moment, in the Java world, you have this group name version convention, so that's the 3 coordinates you use to resolve your dependencies. I explicitly don't edit classifiers here because I think that's not a good concept. It doesn't help you a lot. But what you also have currently is that you have, or that you might need to support different Java versions, or your Groovy developers, I guess. So you want to support different Groovy versions, which are maybe not binary compatible or something like this. But since you're using Groovy, you're a bit more blessed than the Scala guys. But yeah, in Scala, I think each major release breaks the binary compatibility, and at least that was the case a couple of months ago. And so you want to declare, or want to have, if you build something, you want to build it against play 2.10, let's say. And there must be a way to say, okay, I have a library dependency on, let's say, something stupid, foo-bar 1.0, and I need to, where do you define that you depend on the play version, or sorry, on the Scala version 2.10 for that? It's nothing, there's no way to transitively resolve such dependencies. The way the type-safe guys do it is they just add the Scala version, the Scala main version in the name of the artifact and solve it that way, or they have IV repositories where they use, I don't know what they do, but yeah, it's a bit different. So, and if it comes to Android, it's even worse. You have different flavors, you have a free version, you have a product, or yeah, a pro version, or you need different versions for different app stores, or that kind of thing. And for those of you who have ever done native development, it has always been the case. You need to build against different architectures, different processors, different operating systems, whatever. And then another interesting use case is JavaScript. So in JavaScript you have something similar. You have variants. You have maybe the full fleshed out JavaScript, which is good for development. But if you deploy for or build your release, you want to have a minified version or something like this. that's also a good candidate for that variant-aware dependency management. And another thing is that your release process, or whatever you want to call it in a project, you want to have arbitrary dimensions. So, for example, you want to reflect the branch you're currently working on in the coordinates for resolving the dependency. What people at the moment do is that if they do something like this, they just add the branch name into the version name usually. That's how at least I do it in the past. So there's really, that's really a missing feature. Even though we are on the JVM, we are quite blessed, but for the native world, it's a miss. I already talked a bit about parallelization. So at the moment, you can run Gradle with -- parallel, and it will build different modules or different sub-projects in parallel, if that's possible. But it requires you to that the projects you're working on are really and decoupled. So what I mentioned earlier, if you have a sub-project CD whatever, and it references a sub-project somewhere else, without by just changing something, you have a task in that sub-project, and it changes some properties of some other project. We, as a Gradle, the Gradle infrastructure does not capture that, so you can get screwed. So, and we need a way to enforce that, and that's what the new configuration model is about too. Parallelized task execution, so if you have just one project and you want to parallelize in that project as much as possible, it will coming soon. Actually, it's already in the 2.3 release, but it's hidden. If you figure out how to load that, you win. And of course the parallelized configuration phase we talked earlier about. We have a lot of ideas in the future, or for the future, like a shared cache. And that can be implemented in, the way we generally do things is the incremental way, which is, I think, the best way to develop software, is, for example, you can have a shared cache locally on your box. So if you have one build which creates artifacts, it should be possible for another build to resolve them locally and don't need a rebuild or something like this. And then at a later stage, it might be possible to resolve or have a shared cache distributed over the network. So, especially for the CI machines, it's already interesting for having a local shared cache, so that can speed up your CI infrastructure a lot, I think. And you can share artifacts, build artifacts like Java or whatever, or if you're a native developer, some libraries. But you can also think about sharing configurations already, since they are persistent to some degree. One thing we still evolve is the better tooling support. And the Google guys are really demanding in adding more and more features to that, so that we coming from the background writing the build tool, we believe that everything should be done by the build tool. I guess it's native, if you work on that. So what I mean is, the way the Android Studio does it is, I think, the best way to do it, so that you have one unique way to build it, and you have one model to model it. If you look at how things were done in the past, when you download a jar file and you add it and you put it in a zip folder or something, and then you build it, and then you need to configure your Eclipse setup or IntelliJ setup manually. we get in a state where this is not necessary, but for example in IntelliJ you still have the scenario. You can import your Gradle build completely and resolve all the dependencies and blah blah blah. But you still have to deal with the fact that you're using a different compiler, for example, or not all features might be in there, or the goodness Gradle offers, like the incremental compilation support, or the up-to-date checks that are not reflected in the build. And then you have this scenario where, yeah, I don't know, I guess you have those colleagues too, or I had those colleagues too, who say, it's working on my box. So that's pretty cool. Yes. There's a roadmap on our, I don't know if that, use a letter one. Does it work? There's no maybe. Take a look at discuss.gradle.org. We have a pretty new forum. I don't know if you ever used the old forum, but the new one is excellent. I'm so happy that we have a new forum on it. And Hans posted some nice, or posted a summary of the roadmap we are currently on. And everybody's invited to respond to that or provide ideas, and we can discuss stuff. Any questions? We have 2 minutes.
I have a question.
Yeah, go ahead.
The new feature, executing tasks in parallel.
Yeah.
I suspect there's quite a number of tasks out there that's being plugin that's written on the assumption that everything is executed sequentially. So it might be useful.
That's exactly the reason why we need to be careful about that, because there's so much implicit things currently going on. That's a general problem when configure Gradle build in a plugin or a build script or whatever. There's sometimes so much implicit things there developers are not even aware of. I have seen so often that I go to a client and something, and we rework something, and we notice, that just happened to work by accident. Something like this. And the idea of the new configuration thing is also to make stuff more explicit, right? That you explicitly state all your inputs in a more thorough way that you already do now, and that you track the dependencies within the configuration, and you say, okay, the configuration of let's say the task is depending on this and that configuration, and with a parallel task execution, that's a good thing for that. You can enable it by setting a flag. You can, with nothing, by figure out how to do that. But it's on your own risk. It's hidden because we haven't done, or we hadn't the time for doing a lot of checks for the big builds we currently work together with.
I'm a Gradle fan, but I work in a lot of Maven build projects. I didn't see anything about migration or any tool about. Isn't that a concern for you anymore? Claiming projects that are now used on Maven.
Well, there's this limited support for converting Maven builds. We started that out of time. I left out the slides about the init task, where you can take a main build and say Gradle init, and it will or it will try to convert your Maven build. It's not a huge issue, I think, for us anymore, because if it's normal, or it depends on what you're doing with your Maven stuff, but most of the stuff is just converting XML into that dependency notation, and that's something you can do with a couple of lines in Groovy. That's not a huge issue. Or is it for you?
No.
In my experience, the things you can do on top with all the plugins and the constructs you can create with all the plugins to make maybe work the way you want it to work, or try to make it work. This is more of a hassle to people. That is why I'm stuck with maybe with some project as well. Because it's so complicated, it would probably take some days to get a proper Gradle set up, and in some projects you don't get those days.
Yeah, and what I usually suggest is people often mix things up. When they want to migrate from Arndt, Maven, or whatever to Gradle, they do two things in parallel. They convert and try to optimize, and that's a bad thing. The problem, or okay, that's the official term, so we can be talking about Maven. So I think that often the users who say, well, Gradle is too flexible and blah blah blah, and Maven does all that, it works for me. I have the feeling or if you ask them, do you have any pain, and they say, no, everything is fine, and that's for me it's some sort of a often Stockholm syndrome, you know that. So that since you get used to things, you don't even consider it to be changed, or you don't even think about changing that. And that what you have often in builds, it's not generally a Maven thing also, or not an Arm thing. Really, it's a general thing that if you stick to something for a couple of years, let's say, and the build tools are really conservative thing. You usually, if you don't have any pain points, you don't change it. But people just don't know what they can achieve in terms of continuous delivery. They say, okay, it can build my jar. Yeah. I say, if you just need to build a jar for Apache Commons, thing like that, I don't care if it's Maven, Arndt, or Gradle, and it doesn't make a huge difference, right? But if you really are keen on putting your continuous delivery stuff into life, or like things you mentioned earlier in your ASCII.doc talk, where you really want to have custom processes reflected in your build with nice documentation integration, dealing with all that integration tests and all that kind of stuff. Yeah, that's what you can easily do in Maven. So in general, I suggest convert your Maven if you want to convert something, or you want to use Gradle and do more stuff. Convert your build as is with all the twerks and whatever. So and then when it's building with Maven or with Gradle, sorry, then start improving it or start looking into optimizing it. And the nice thing is that you can do, my first Gradle build in my former company, what we did is we just added another build. We ramped up the Gradle build in parallel to the Arm one, and once you have the same output, you can ditch it.
We did that when we converted ASCII.doc.
Yeah. That's a general issue that people try to do too much in parallel at the beginning, and then they fail for not used to it, not learning the learning curve, and then the Maven guys say, "I told you so," and that's nothing you can do. Yeah.